Precalculus. We had a very long, fun warm-up. Today's date is February 12th, 2/12. We have the notes in front of us. All right, let's unfreeze the screen so you can tell what's going on. We have these notes on vocabulary. I told you I would be asking these definitions, and here they are. Recursive. What does that mean? That's finding what?
Oh, wait.
Go ahead and look at your notes. Recursive means find the...
Wait, oh, the pattern. The line.
No,
the order.
The list.
Order.
List.
List.
Look at your notes. I love the energy, but look at your notes.
Wait, the recursive to find the list.
Nope.
Next.
Recursive means you can only find the next value. Recursive, you have to find the next, then the next, then the next. I can't
That's
jump
a
ahead in
list,
time.
Though.
Well, both of these are finding a list, so that's not helping us.
Boom.
So find the next. Write it down in your notes. The main point here is you can only go one by one. If you want to write that down in the notes too, you can. You only go one by one. You can't jump to value 100. Today, we're going to jump to value 100 without going one by one by one by one. So explicit means find what? Any, exactly. Find any value. That means you can jump right to 100. All right, so this all comes back to Algebra 1. I know that we're in Precalculus. We took Geometry, then Algebra 2, and now we're taking Precalculus, so it's a long time ago. But Algebra 1, linear equation. So say we have this table. Let's go ahead and graph these points. 0, 3, graph it. Where does 0, 3 go? Is it right there, or is it right there? Where's 0, 3? Is it that one, that one? Where's 0, 3?
Whoops. 0, 3 is on the y-axis.
It is on the y-axis. 0, 3, and then 1, 5. 1, 5, then 2, 7, then 3, 9, etc., etc. Can you find a linear equation that has those points? Y equals mx plus b. You remember him?
Yeah.
Y equals mx plus b. All right, what is the equation then? Y equals what?
Y equals the y. So it's like, say we use 3.
What?
M represents slope.
Oh, so it's 2. 2 over 1.
Yep. So it's going to be 2 over 1, or just 2x, and then plus b plus
3.
3.
Or
There it
like
is.
any of the y's.
It has to be the y-intercept. This guy right here is the y-intercept. Y-intercept, which is 3. All right. So super related. So if I were treating these numbers 3, 5, 7, and 9, and I say that is the first value because it has the 1, right? That means I want my first value to be 5. So if I plug in 1, I should get 5, theoretically, right? So I can just use this formula. The first value, I'm plugging in 1 and I get 5. Can we see how that works? So how do we get that to work for our explicit formula down here? Why do we have an n minus 1?
Because it's if you don't have the table.
Yes, so we don't have a table anymore. I guess the problem here is, what is this guy right here, 5, in terms of this table?
That is when it's 0 equals 5. So
Say,
when x equals 0, y equals 5.
but this equation does match this table though. And when we had x equals 0, we got 3. Should that be a 3?
It's if you don't have the y-intercept. So like say there was never a 0, 3, and only gave you 1, 5. So it's basically, how do I explain it? I the 5 came from the 1 up there.
Yep, so I think you're thinking of point slope form. Point slope form says you do n minus the x coordinate, and then you do
So
y
like-
minus the y coordinate, and then you add the 5 over. Yes.
So like say it says if n equals 7 plus 2, n minus 2.
And then plus 7, right? Yep, exactly. It's from point slope form. Usually, we always start with the first term. Again, I read this as the first term, and you can write this in your notes. That a of 1, that's the same thing as saying the first term. First term. So in order to have the first term in the sequence is 5. I don't say the 0th term. I usually start with the first, right? I don't start with the 0th. I start with the first term. If I start with the first term, then I'm going to put a of 1 there. And then because I start with the first term instead of the 0th term, I now have to do an n minus 1 instead of an n. Are we okay with that?
Can you repeat that?
So because I'm starting with the first term instead of the 0th term, for your slope-intercept form, you started with the 0th term right here, 3. But when we talk about numbers, we don't find the 0th term. We start with the first term. So in order to have the first term, instead of this, it used to be plus 2x like this, 2x and 2x. These guys matched up.
Well, it's kind of like, if you can see it this way, it's 2x plus 0, 2 times x minus 0.
So now I have to do x minus whatever the x coordinate was.
Yeah.
It used to be x minus 0, now it's x minus 1 to shift it back so that I can use the first value there.
Okay, makes sense.
So far, so good?
Yeah.
Okay. So in our explicit formula, this is going to be, let's write it down, this is our nth value. Nth value. That means if I plug in 5 for n, then I'm finding the 5th value because I'm just plugging in 5 for n for the phrase as well. This guy is our first term. We've already analyzed that. And this is our rule. I guess our rule really comes from here. Add 2 each time. Add 2 each time. That's our rule. I'll put in parentheses here. That's our rule. Every single time you'll always have n minus 1. So you will always have n minus 1. And again, if you want to write that in the notes, that's because you start with the first term. Start with first term instead of 0th term. All right, so we have a few different homework assignments tonight. I think we have 2 homework assignments tonight, according to our unit guide. Should I pull up the unit guide so we can actually see what's going on? So on our unit guide, we're in Precalculus. So we actually have 3 homework assignments tonight. So one of them is using the formula, and these first 2 go by so fast, and this one is still easy. All 3 of them are easy. That's the reason I assigned so many. First one is, can you use the formula when they give it to you? The next one is, can you find the next one in the pattern? Both of those are really easy. Those are like warm-up worthy questions. And then finally, making your own explicit formula. It's still pretty easy, but it's the more challenging between the 3. So example 1 corresponds to homework problem number 1. Find the 11th term in the sequence. Plug in 11. So how do I do this? To find the 11th term, well, that's the 11th term, so I'm going to do b of what?
11.
B of 11. This literally reads the 11th term. The 11th term is, equal sign means is. The 11th term is, and then I just plug in everything on the right hand side as well. Minus 3 plus 5 times, what am I plugging in for n again? 11 minus 1. And let me back up here. I can do the 11 in yellow to make it pop out more. 11 minus 1. This guy right here, I'm going to change to yellow as well, so we can track that. Okay, now I need to simplify. Let's do some mental math. Ready? 11 minus 1.
B of 11 equals 47.
Well, b of 11, keep this as b of 11. It is read as the 11th term.
So find the 11th. Okay, so 11 minus 1 equals 10 times 5 equals 50. 50 minus 3 equals 47.
That's the answer. The answer is 47. And I read this, I still have b of 11 on the left-hand side, b of 11. I read this, the 11th term is 47. That's what that line reads. The 11th term is 47. So far, so good? That's one homework assignment. Think we can plug in things? All right, let's do the second homework assignment. Find the next term of the arithmetic sequence.
This one's kind of messed up, not gonna lie.
This one,
Like, it doesn't seem right. It's like negative 3 quarters
Oh.
7 equals
I made a mistake again. Oh my gosh. Change this to a 4. Then it's fine. It's a -4. Then it should work. You are totally right, Rochelle. Can you give yourself an extra credit point? And
Yeah.
all right, thanks. Should be -4. -4, then -7, then -10, then -13. Then what are the next ones?
Then it's -16.
-16. And that's all it's asking for. It's just the next term, it's -16. Then I could go again if I wanted to, it's -19. I could go again if I wanted to, -22. It's only going to ask for that first term, though, -16. So far, so good? That is another homework assignment. It's super easy, though. Yeah? All right. And then finally, the explicit formula. That's going to be the hard one. I have 2 examples. Example 3 and then one on the back, example 4. This one can be a little bit tricky. Again, you will always, always, always have n-1. We have that in our notes. So let's set up our problem. What letter do we want to use? You could use A, you could use B, C, D, E, F, G, all of those. Which one do we want to use? You can do heart. You could do smiley face. Literally choose a symbol.
Oh, star.
Star, okay. Our function is going to be star of n is equal to. Usually you do n for your variable. You could technically choose a different variable if you wanted to. Star of n is equal to, okay, well, what was our our first term? This a of 1 is our first term. So what's our first term? There it is, 8. Now I'm going to do this thing. The pattern, the rule. Well, what is the rule here? What did I do each time?
You do a +7.
+7, and then I always, always have
n-1.
n-1. I'm going to put that in red because you always have this. n-1. You always have that. Done. You just solved it. You think you can do another one? Let's try it. Example 4 on the back. Daisy, you're going to do this whole one for us. Choose a symbol or a letter or something. Heart. All right. Heart of n is equal to what?
Oh, I'm sorry. 36.
36? Yep.
-8. Right? Is it 8? Wait, is it 8?
18 to 9?
9, sorry.
Yep. -9 times.
Times n -1.
There it is. Done. I think you both can do all 3 of those homework assignments. It's a lot of work, but it goes really, really quick. I think we can finish today, even though we had a really long warm-up. Any questions? All right, that concludes the notes.